Hello, everyone, and welcome back. I hope you had a great Memorial Day weekend, 3-day weekend there. We're going to go ahead and do our next lesson tonight, which is on decimals. This is level M, lesson 3 on decimals. I think after this, I'm going to double check this real quick. I'm pretty sure after this we have one or two more things in level M, and then we're going to move on to the next level, which is the A level. One second. I'm just double checking my list here. One second. Yeah, decimals. Oh, we have four more things. Wow. Okay. So actually, there's a little bit more inside of this, inside of level M. We're also going to be talking about measurement, graphs and charts, lines and angles, and basic statistics. And then actually, I misspoke. The next thing after this would be level D and then level A. So moving right along, we're progressing right through. We have plenty of time to get through everything that we have to in this course. So let's dive in and start talking about decimals. So there's four things we're going to discuss when it comes to decimals. The first thing is going to be about what is a decimal, how do you read it, what is the parts of a decimal. So a decimal represents a fraction or a part of a whole number. So and a decimal is a combination of the whole part and then a decimal point and then the decimal portion, which represents actually a fraction. Let's give you an example of a common fraction or common decimal that you're probably used to, and that would be 1/2. That can be represented, actually, any fraction can be represented as a decimal, and 1/2 is represented as 0.5. So, another way to think about half, right? If you have an object and you cut it in half, you took one whole object and then you divided that object into two. And that's where this fraction comes from, and that's how the decimal is formed. Half of a whole is going to be 0.5. That's an easy decimal. If you had an example like 12.5, that's the same thing as saying 12 and a half. So decimals represent fractions of a whole number, and they have a place value. Every digit that you add on to a decimal has a place value, and we're going to go over what those place values are today. Now, I didn't write this in the notes, so you're going to want to make sure that you jot this down and add this in. There's two kinds of decimals. Okay. So the one kind is called a terminating, or another word for that would be a rational. That's a number that has like a finite ending. So like 12.5 is an example of a terminating or rational decimal. You can think of the word terminating like the end of something. So this number stops. It's 12.5 and then it stops. You don't. There's not like a whole bunch of crazy decimals after it. And then you could also have ones that repeat, like 3.333, and sometimes you're going to see this little symbol at the top of the last number. What that means right there is that that point 3 just continues on for infinity, like it never stops. Okay, but that's still considered a rational number. Actually, 0.33 repeating represents a third. So if you were to take an object and cut it into three pieces, then the decimal representation of that is 0.333333333 forever and ever and ever. So anyway, the other type you could have would be like an irrational one, or one that is like non-terminating. But the most obvious characteristic of this would be when you have something like just some random mishmash of numbers that really don't make any sense, like 4.739214978865 dot dot dot. Like it just keeps going on forever, and it's a bunch of random garbage numbers. Another example of something that's an irrational number that you may have seen before would be pi. If you've ever seen the symbol pi, or you've seen even the definition of what pi comes out to. Pi is, I shouldn't put equals, I should put approximate. Pi is approximately 3.14159 dot 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 because it's an irrational decimal. It just goes on forever and ever with a bunch of random mishmash numbers there. Okay, so that's two kinds of decimals. I don't actually think you're going to see that in this particular part of like when you go through Essential Ed, but still good information to know. So let's talk about place value. Let's transition to talking about place value. Okay, so place value basically talks about the placement of the digits that are in a number. If you look at a whole number, this doesn't have any decimals. It's just a whole number, 327. We covered this, I think, in a previous lesson. But the 3 here is in the hundreds place, the 2 is in the tens place, and then the 7 is in the ones place. So those are our place values. Notice that as you keep going towards the right here, the place value is like 10 times larger than the previous space. So 1 times 10 is 10, and 10 times 10 is 100, and the next place would be the thousands because 10 times 100 gives me 1,000. Okay, so that logic applies still when we're going the other direction, which would be, I don't even know if this is the right direction on the video, like for you guys, so just if this is not left for you, then just ignore my thumb, So the other direction you can go is to the, I don't even know why I said left, I meant to the right. My direction's all over the place. This quarantine is it's like frying my brain. Okay, so you could have a number that is that has a decimal. Your whole number part is over on this left side of the decimal point, and then your decimal part is on the right side, and you have that decimal point in the middle. The 0.591 part represents the fraction or the part of the whole number. And then each of these values here has a place value. This is the tenths place, this is the hundredths place, and this is the thousandths place. Now, keep in mind, there's a difference there between the other side, the whole number side. On this side, we're talking about ones, tens, and hundreds. On this side, we have this th at the end of the word, tenths, hundredths, and thousandths, okay? That's the difference. So that's going to be your context clue, the thing you have to look for, especially in problems that are asking you like to round to a certain value or something. You're going to want to make sure that you can identify what place value it is they're asking you to round that number to. So in this example, the 5 is in the tenths place, the 9 is in the hundredths place, and then the 1 is in the thousandths place. Okay, this is actually a really great resource for decimals. If you pull up, I think I can add this link to our lesson on Google Classroom also, but if you pulled up this notes document, before you print it, you should be able to click right on this. If you can't, I'm sorry, just type this right into your browser. But this is a great educational resource. Math is Fun has a lot of great explanations for different things, but their decimal one is pretty good. That's actually where I got these 2 graphics from. So if you want to check that out, that's a good thing to go look at. I have a very good place value chart for you guys here in the notes. So if you printed this out, great. If you're writing your own notes, then you're just going to want to write this chart down. The decimal point that we are talking about in this particular, this example, is right here. So there actually should be a decimal right here. And then to the left of the decimal point, we have all these whole number place values all the way up to the millions place. And then to the right of the decimal, we have tenths, hundredths, thousands, and 10,000ths. You'll find, I think, that the majority of problems that you do don't really require you to go any further than the thousandths place. You might get a 10,000ths place, but that's probably the most you're going to see. Okay. So that is the language of decimals right there. We have a concept called rounding, which is what we're going to talk about next. When you are rounding numbers, it's basically like cleaning the number up. It's basically like getting rid of all of the extra information the number is giving you that you might not necessarily need. And you can round up and you can also round down. And everything that you do when you round is dependent upon the place value. So in the example I gave in the notes here, if I'm having a party, let's say I'm having a party, and I know for a fact that there are exactly 47 people coming to this party, right? That's good information. I should know that there's going to be 47 people here. There may be certain instances I need to know the exact number of people. For example, if I'm going to do like party favors and every person gets one thing, I'm going to make 47 of them. I'm not going to make, well, I might make extra, but anyway, that's not the point. The point is there may be instances in this party planning where I need to round the number. I don't need to know necessarily that there's exactly 47. I might be able to just say it's about 50 people, and that's enough information for me. For example, if I'm buying food or ordering pizza or something, I might order enough for 50. Or I might even go higher than that if I expect people to bring people with them. But approximately 50 people are coming, so it's easier for me to buy things like food and drinks in quantities that are like nice, even, whole, clean numbers, like 50, than it is to be like 47. I might wonder, like, 47. How many pizzas do I have to buy 47 slices exactly, or something like that? And that's too much, too specific for the application, for the problem I'm trying to actually do. So the first thing you want to do is you want to identify the place value the problem is asking you to round to. And the problem should basically always give you this information. It might say round to the nearest whole number, and you're basically going to be getting rid of all the decimals. The trick to this is getting to know the place values, though. So let's do some examples. So the first one says round 2.16207 to the nearest tenths place. And be careful here, like I was explaining before about tens versus tenths place. The th part at the end here makes a huge difference. They want us to round to the tenths place. That's the first place value of the decimal. So this right here is the tenths place. That is the place value of tenths, and there's a 1 in that slot. And the question I'm asking myself now is, am I going to round this 1 up to 2, or am I going to round it down to 0? Okay? And all of that is dependent upon whatever number is immediately to the right of that number. So in my hundredths place, my next place value here, we have a 6. Okay? So if the number to the right, is that even English? To the right, there we go. Well, sort of. It's still a little scribbly, but you're listening to what I'm saying, hopefully. The number to the right, if it is greater than 5, greater than 5, or exactly 5, you go up. If it is less, what am I even writing here? This is just crazy. Let me just erase all of this and write like a normal person. Hold on. Okay, so if the number to the right is 5 or higher, then you round up. If it's 4 or less, then you round down. Okay, so let's apply this definition to the problem we have in front of us. We're rounding the tenths place, so let's go to the number to the right, which is a 6. And 6 being greater than 5 means I'm going to round up. So my answer here is going to be 2.2. You take the number that's in the place value and you go up to the next highest digit. That's the gist of it. Next example is round 8.4765 to the nearest thousandths place. Thousandths place means that we're looking at one of the numbers that's in the decimal place value. I want you to pause the video, refer to your chart for the place values, and then round this number and see if you get the correct answer. Okay, so when you round this problem, we're looking at the thousandths place, which is right here. And we're going to go to the number immediately to the right of that to figure out if we should bring 6 up or bring 6 down. Because the number to the right is 5, that means we're going to bring 6 up, which means my answer is going to be 8477. And that is rounded, okay? The rest of the lesson tonight, right, is talking about how do you compare two decimals and decide which one is larger than the other, because sometimes that can be tricky. So we're going to do that. And then there's going to be some information for you about adding and subtracting decimals. Now, I actually found a perfect video to explain adding, subtracting, multiplying, and dividing decimals. So my part of this lesson is going to stop after the comparing decimals part. And then I'm going to leave some blank space for you in the notes. That way you can go ahead and watch the video that I'm going to share with you about adding, subtracting, multiplying, and dividing those decimals. Okay, so let me switch colors. How about bright green? Let's do some bright green. We're going to talk about comparing decimals. And all we're being tasked with here is deciding if one is larger than the other. And there's a strategy that we can use called where we add zeros in like placeholders, and then we compare the two numbers. So if I asked you what quantity is larger, if I have 3 apples in one hand and 5 in the other, it's easy to say that 5 is larger because that number is bigger. But what if I gave you an example of 1.59 grams of something in one hand and 1.6 grams in another hand, okay? That might not be immediately apparent to you which one is larger, and the way you can compare the numbers is by looking at the decimal places. So what you're going to do is line the numbers up. So you're going to line up 1.59 and 1.6. And when I say line them up, I'm talking about the decimal point. Line up the decimal. Now you can see in 1.59 we have one additional digit here that we don't have in the second number. And so in the second number, I'm going to insert a 0 like a placeholder. That 0 is actually there, okay? In math, there are actually things called significant digits and significant figures. And I could go on forever and ever and ever on both sides of these numbers with zeros, because 0 is like no quantity at all, okay? So theoretically, I can add 0 or subtract 0 or whatever to any value, and I'm not actually doing anything to that value. This 0 doesn't make 1.6 bigger or smaller or change in any way. All these zeros exist here. It's just that in science and mathematics, usually what we do is we pay attention to significant figures. These zeros, since they have no impact on the 1.6, the 1.6 is the part we actually care about, we usually just leave all these zeros off, okay? Now, I'm going to add the zeros because I need them in order to compare these two values. So here's the 1 0 that I'm going to add. And now I have the same number of digits in both parts. And so what you're looking for is you are looking to see, so what you're looking for actually is you're going to go from the decimal point to the first place value and then compare which one of those pieces is larger, which number is larger, and that's going to be your answer. This one's pretty easy because at the first place value, we were good to go. We know that 6 is larger than 5. So bingo, this number is the larger one. The tenths value is what we compared. But what would happen if the tenths value was the same? What if the hundredths value is the same? And then what if the thousandths value is the same? Well, we may have to just keep comparing place by place from left to right until we find which piece has a larger number. So let's do the next example. We have 3.492. And then we have 3.4912. And so we're going to start here at the first value. Oh, I forgot to insert my tens. Sorry, this needs to be here. So we're going to go to our first value, our tenths value. They're the same. The second value is the hundredths value. These are the same, also 9 and 9. So these numbers are pretty close to each other. The next value is the hundredths value. And we can already tell here that 2 is larger than 1, and so this is going to be our answer, okay? What if it was the other way around? What if this 1 and 2 had switched, like 3.492 and 3.4921, like that? So these are the same, the same, the same, and then this one would be larger, okay? So you just got to pay attention to the place values and see what's where. So the next part of this lesson is going to be adding, subtracting, multiplying, and dividing decimals. And like I said, I found a really great YouTube video from this guy called the Organic Chemistry Tutor. He has tons of math videos. He's really chill, you know, but he does a really great job explaining it, probably better than I could do. And so why reinvent the wheel? We're just going to go ahead and watch his lesson. And then once you're done with this lesson, I have a Delta Math for you, which only has 10 questions. It's about rounding. And then you can go ahead and work on your Essential Ed. Okay, so go ahead and transition over to that other video, and good luck. And if you have any questions, make sure you reach out to me. Thank you, guys. Bye-bye.